Good afternoon, everyone. My name is Daryl Joe Santos, and today I would like to discuss my research entitled Environmental Effects on Aging Activities from an Extinction-Free Mid-Infrared Census. So first, let us discuss what are active galactic nuclei. As mentioned by the previous speakers, these are manifestations of the accretion of supermassive black holes, which are believed to reside at the center of most galaxies. Understanding them is very crucial to study the so-called black hole galaxy coevolution. In this scenario, as you see here in the figure, the black hole growth is correlated with their host galaxy's growth. But there are still mysteries surrounding this black hole galaxy coevolution. And one of this is the role of environment in this scenario. There are still galaxies living in cluster or denser environments, or field or less dense environments. And we want to know the role of galaxy environment in this scenario. Let me give you a quick analogy of this problem. So here's the main question of this research. So if AGNs were humans, in which part of Taiwan do you think they would most likely to live? I can give you two options, Taipei or Hsinchu. We want to use these cities as representation of the two ends of the spectrum for describing galaxy environments, with Taipei representing the more or denser environments, and Hsinchu representing the less dense environments. We want to focus on obscured AGNs, AGNs that are not observed by X-ray, radio, and optical telescopes because of their sensitivity limits and dust extinction problems. However, with mid-infrared census, we can actually observe these obscured AGNs because dust emits radiation in the mid-infrared region. However, there's another problem. Because AGNs and star-forming galaxies are all bright in mid-infrared. AGNs produce this red power loss spectrum, while star-forming galaxies produce this pulse-cyclic aromatic hydrocarbon emission. So, classifying an object, whether it's AGN or star-forming galaxy, in the mid-infrared is hard if we don't maximize the wavelength range of our observations. We cannot do this with WISE and Spitzer telescopes because there are gaps in their filter coverage. So if the spectral features of our objects are lying on these gaps, we cannot observe them. However, with the Accurately Infrared Telescope, we can actually observe these missing spectral features because of the 9-band continuous filter coverage, which is very good to cover these mid-infrared features. Now, to summarize our sample selection, we did two separate calculations. The first one is calculating the environment of the galaxies by using density. Density in our research is related to the distance from the 10th nearest neighbor, and we calculated the density using optically selected galaxies in the HSC survey. And we calculated the density in a volume-limited sample of this particular redshift and this particular magnitude cut. We also constrained the galaxy properties of our sample using a spectral energy distribution, or SED fitting code, called SIGAL. We selected the galaxies that are detected in both mid and far infrared in this Accurately North Ecliptic Pole wide field. The reason why is because, as you can see here, the North Ecliptic Pole wide field is observed by not just Accurately, but other telescopes like HSC, WISE, Spitzer, giving us a multi-wavelength or panchromatic data for our objects. If you want to know more about this, you can go to our collaborator who collated this multi-wavelength data, and he has a poster there. So we cross-matched these two particular calculations, and we got around 1,200 galaxies at this redshift with density values and good SED fits. We want to conclude our results based on which type of infrared galaxies they are, based on their total infrared luminosity. So infrared galaxies, ERGs, and then we call them luminous infrared galaxies, LIRGs, and then ultraluminous infrared galaxies. Take note of their pictures because we'll use them for our summary later. So we have a secondary question. For the infrared galaxies that I showed, do they have a preference in Taipei or Hsinchu? And we actually have an answer for that. The more luminous infrared galaxies are, the more they prefer Shinchu, or less dense environments, as you can see in this histogram. And there are other studies that are also saying the same thing, because in less dense environments, they say that the relative velocity of the galaxies are smaller, giving them more frequency in dynamical merging. This also pushes the fact that ULERs might be merger systems. Now, the main question is, do infrared galaxies prefer Taipei or Hsinchu? Place your bets, because there are no trend that we didn't find any trend for the infrared galaxies and luminous infrared galaxies. Only for ULERs, we find that the AGNs prefer denser environments. As you can see here, the AGN number fraction increases with the normalized local density, so the number of AGN over the total number of galaxies in the density bit. The AGN contribution fraction, which we use as a probe of the strength of the AGN, it also increases for ULERs with denser environments. Some studies are showing this kind of result, probably because AGNs might be stimulated by environmental effects. But this is still a work in progress, so this particular result is an interesting scope to look at. So, for the big picture, we have here Hsinchu and Taiwan. We found out that the more luminous infrared galaxies are, the more they prefer Hsinchu, or less dense environments. However, for ULERs, we see that their AGNs are stronger, and they thrive or live more in denser environments, or in our case, Taipei. This ends or concludes my talk. Thank you very much for your questions.
Any questions?
Good talk. So I just wondering if there is any physical reason why ultra infraluminous galaxies like to live like denser environment.
That's a good question. Actually, this is still a work in progress. So having a conclusion at this early stage is still hard to do. We still need to look at the cluster field classification and cluster-centric distance to have a good possible scenario to explain this, why ULERs only show this particular trend. However, we have some preliminary hypotheses. As I said a while ago, AGN might be stimulated by environmental effects, which is shown by other studies, but in different wavelength ranges, like X-ray. Some people are also saying that obscured AGNs might be stronger at denser environments. And if ULERs are, we can tell that ULERs might be having obscured AGNs, then that might explain why we're having this kind of result.
Okay, so if no more questions, I think they will